Hello all, today we are covering lesson 12.2, surface areas of prisms and cylinders. You guys will be able to find lateral areas and surface areas of prisms and find lateral areas and surface areas of cylinders. So our new vocab is lateral face, lateral edge, base edge, altitude, height, lateral area, axis, and composite solid. So we have lateral areas and surface areas of prisms. In a solid figure, faces that are not bases are called lateral faces. So in this case, this would be considered a lateral face. Lateral faces intersect each other at the lateral edges, which are parallel and congruent. So where two lateral faces intersect, that is called a lateral edge. And these lateral edges are the same length, they're congruent, and they're parallel. The lateral faces intersect the base at the base edges. So these are all considered base edges here as well. The altitude is a perpendicular segment that joins the planes of the bases. The height is the length of the altitude. So notice it has to be a perpendicular segment. So an altitude on a right prism is just one of the lateral edges. It's perpendicular. It is also the height. We have the oblique prism. The altitude is not the same as the lateral edge. It has to come down at 90 degrees. And the altitude here is then the height, okay? So recall that a prism is a polyhedron with two parallel congruent bases. So these are congruent bases and they are parallel to each other. In a right prism, the lateral edges are altitudes and the lateral faces all are rectangles. So notice all the lateral faces are rectangles in a right prism. In an oblique prism, the lateral edges are not perpendicular to the bases. You notice they don't form 90 degrees. And at least one lateral face is not a rectangle. You can tell here this face is a parallelogram. The lateral area L of a prism is the sum of the areas of just the lateral faces. So it's just the rectangles or the parallelograms if it's an oblique prism. The net at the right shows how to find the lateral area of a prism. So if you notice, we have the net. This would form this 3D solid. If you look here, the lateral area is actually just a rectangle. A, B, and C are the perimeter of your base, and then you multiply that by the height to find the lateral area. So that's all it is. The lateral area of a right prism is the perimeter of the base times the height. So find the lateral area of the regular hexagonal prism. So we have to find the perimeter of the base times the height. So 5, and there are 6 sides since it's a hexagonal prism. So 5 times 6 will give us our perimeter, which is 30. And then our height is what connects the two bases together, which is 12. So we end up getting 360 square centimeters. Now notice it is square centimeters because we're still talking area. We're going to do another one. Find the lateral area of the regular octagonal prism, or octagonal prism. Once again, lateral area is just the perimeter of the base times the height. So we have a 3 for one side. We can multiply that by how many sides there are. We get 24 centimeters for the base, and then the height is 9. When you multiply those, you end up getting 216 square centimeters. Now, if we're talking surface area, that is actually the area of all sides, the bases and the lateral area. So right now, all we would have done is the lateral area. If I draw a net of, say, that triangle like we had before, not necessarily to scale. I'm not a super great artist. So far, we've only found the area of the lateral faces. The surface area is just finding the area of the whole thing. So we have the lateral area plus our two bases. Now big B stands for area of the base. Okay, and we have to multiply it by 2 because there's 2 bases. Anyway, you have to have the variable big B, capital B, because not all bases are triangles. Sometimes they're pentagons, sometimes they're hexagons, octagons, squares, rectangles. You name it, okay? So that's why we have this big B standing in. So let's do it. We're going to find the surface area of a rectangular prism. These ones maybe are the most difficult because it's hard to tell what your base is because they're all very similar. I'm going to make my base in this case these squares, which means I need to find the perimeter to find my lateral area, and then need to multiply it by my height. So my perimeter is 6 times 4, because there's 4 sides. Need to multiply it by my height, which is 12, so 24 times 12 will give me my lateral area, and then to that, I need to add 2, and then my area of a square is just base times height. So 2 times 6 times 6 will equal 72, and when these are added together, we get 360 square centimeters. If you had decided to make a different set of sides, bases, say you wanted to make this a base and this a base, that would be totally valid. You just have to plug your numbers in different spots. Okay? Now we need to find the surface area of this triangular prism. I will say, if you have learned it before, that you can go ahead and find the area of this guy and then add the area of this lateral face, and then add the area of this one, and then add the area of both triangles. That will totally work. You don't have to use the surface area equals lateral area plus the 2 bases. It's just kind of a succinct formula to be able to use, and why I'm using it. So first we need our perimeter times our height for our lateral area. We don't have all the side lengths of the triangle, nor should we assume that it is equilateral. So I'm going to solve. I know these are congruent, and then that these will be congruent. So I'm going to use Pythagorean theorem to solve for my hypotenuse. So it is not equilateral. Good thing we didn't assume that. I can now find my perimeter, which will be 32 because 10 plus 10 plus 12 is 32, times my height of my prism. The height is what connects the 2 bases. Then I need to find the base. This time it is a triangle, so it's base times height divided by 2. So the base of my triangle is 12. My height of my triangle is 8. I divide that by 2. Notice I can cancel these 2's out, so I do. So I end up getting 320 plus 96 is equal to 416 units, or square units, I should say. Okay? All right, now we're going to move into lateral areas and surface areas of cylinders. The axis of a cylinder is the segment within points that are centers of the circular bases. So if you think kind of like a toilet paper roll, where you hang it is considered the axis. Goes right through the middle. If the axis is also an altitude, then the cylinder is a right cylinder. Notice how the altitude comes down at 90 degrees, the axis goes right through the middle. If the axis is not an altitude, then the cylinder is an oblique cylinder. Notice how it's on the outside, drops down like that. It's not through the center. The axis and altitude are different. So the lateral area of a right cylinder is the area of the curved surface. Like a right prism, the lateral area L equals the perimeter times the height. Since the base is a circle, the perimeter is the circumference. The circle will then have a lateral area of 2 pi r times height. So notice if you take a cylinder and you break it apart into its net, it's a rectangle with 2 circles. You could fold that shape into a cylinder. So you have to find the perimeter of the circle and then multiply it by the height. And then the surface area of a cylinder is the lateral area plus the areas of the 2 circles. So we can use this equation, oops, I'm going to highlight it, for our surface area and this one for our lateral area. So find the lateral area. Lateral area is just circumference, 2 pi r, times the height, and then we're going to find the surface area. So I just plug in what I'm given, 2 pi times my radius times my height. So 2 pi times 14 is 28 pi times 18. If I go ahead and finish this out, I end up getting that this is equal to 1,583.4. Now that's my lateral area. I'm done with my lateral area. My surface area, on the other hand, not quite yet, although I do need my lateral area plus 2 times my circumference, pi r squared, sorry, not my circumference, my area of my circles. So one circle is pi r squared, but there are 2 of them, so we need 2 pi r squared. So we know this L, lateral area, is coming in here. We can finish solving for our areas of our circles. So I need to take 14 squared first, and then multiply that by 2 pi, and I get 1,231.5, and then I can add my lateral area to that, and I get 2,814.9 square feet for my total surface area. Okay? Now we're going to do the same thing again. Find the lateral area and the surface area of this cylinder. So lateral area is perimeter times height, but in this case, perimeter is our circumference. So 2 pi r times height. We're just going to plug it in. So 2 pi times our radius 12 times our height of 20. So we have 24 pi times 20. And we get that our lateral area is 1,507.96. We'll have to probably round to 80 because it wants to the 10th. And that is square feet for our lateral area. And then our surface area is the lateral area plus the 2 circles area. So 2 pi r squared So we have 2 times pi times 144. So 2 pi times 144 is equal to 904.8. Go ahead and bring the lateral area down. And we will add these together to get our solution. Which is 2,412.8 square feet for our surface area. Okay? So that is lateral area, that is surface area. In manufacturing, a soup can is covered with the label shown. What is the radius of the soup can? So, doesn't show the whole net, but you could say, okay, there's some circles up here. This guy is actually just the circumference of the circle. So we know circumference is 2 pi r. That will equal the length of our rectangle. And we can go ahead and solve. So I'm going to divide by 2 pi. And we actually get that our solution is about 2.5 inches. So we know, based on our nets and what we were just solving, that this is our circumference. And then you just set it up to solve for radius. Now we're going to find the diameter of a base of a cylinder if the surface area is 480 pi square inches and the height is 8 inches. So we have a little more to do here. I'm going to draw out our net. We know our height here is 8. We know our surface area is 480 pi. We are trying to find the diameter, D. Okay, so this one is a bit of a tricky one. We want to use our surface area equation, which is 2 pi r times height, plus the area of the circles, 2 pi r squared. Now we do have some information we can plug in, but not really a ton. We know the surface area is 480 pi, 2 pi, we don't know our radius, and we do know our height, and then 2 pi r squared. Now, I'm going to do as much as I can to this point. I just combined my 2 and my 8, pretty much. Now, it would be nice if I could just go ahead and divide by 2 pi on both sides and get a solution and go from there. But because of this addition sign, oops, we actually have to do something a little different. I'm going to find, it's going to look like dividing, I suppose, my greatest common factor of both of these terms. It happens to be 2 pi, and I'm going to pull that out. That way, if I were to distribute, it would get back to the original. Oops, that would not get back to the original. It's just 8. There we go. That would get back to the original as such. Okay? Oops. from here, now I can divide both sides by 2 pi. And I now have 240 equals 8r plus r squared. And yes, we are going to have to use quadratic again. I'm going to subtract 240 on both sides, and then I'm going to rearrange my quadratic to be a little prettier. Now, I'm going to have to solve this quadratic. I'm going to try by factoring. I personally like factoring better. So I'm going to take 240. I'm going to divide that by 24. I know that's divisible. It's not quite right. 25 is not good. See if I'm getting anywhere. So it looks like I'm getting maybe further away. So I'm going to go 23. Oh, looks like that's good. So it looks like you divide it by 20. One must be positive, one must be negative. So 20 times 12 is equal to 240, and then 20 minus 12 is equal to positive 8. So when I solve both of these, one becomes positive, one becomes negative. This one's no good, you can't have a negative radius. But positive 12 is good. It is asking for the diameter though, so you need to take this times 2, and you get 24 inches is your diameter. Alrighty, that's all I have for you today. Have a great day.